What's up, friends? Today we are here with a new video in the Revisiting board series, and this baby in the back here, this is my SR-71 Bluebird build that I made in 2020, and today we're going to be upgrading the battery pack from the super old 30Q cells to these Molicel P26As. And it's going to take a bit of doing, but this is a much needed upgrade in order to continue my wheel testing videos. So let's jump right into it. Alright, so for a little bit of background on this build, I built one board before this one, and that was my one that I made a video on a super long time ago called Revisiting my first DIY build, and that was with lipo cells and the box ESCs. This one was my first more expensive DIY build, and it also contains the first ever battery that I built out of 18650 cells, and that was a 12S7P of 30Q cells. Those 30Q cells that I had, they're in here still, were reclaimed from Rebel Kit battery packs that I took apart, and the capacities varied a bit and the ages of the cells varied a bit, but I kind of tried to spread out the ages throughout the different P groups so that they would discharge evenly. Ended up lasting easily about 3 years, and I was able to get close to about 20 miles per charge on it, and that kind of went down with time, and now we're at the point where one of my P groups, I think P group 7, which would be right here, I believe, is a lot lower than the other packs. I'll put a screenshot on screen, but yeah, it's too low to keep riding comfortably. The other groups are at least 0.3 volts higher when I get down to the end of my charge, so it's time to upgrade, and I think that's the only thing I'm going to be upgrading in here right now, so I can get back on the road and start doing more efficiency tests, because there's some cool wheels coming out in the future, the radium wheels. I need to do efficiency tests on the V2 mad wheels, which I expect will be almost identical to the first one. But yeah, I'd like to have this board back and running. So a couple things to do. We've got to open up the board, pull out the old pack, double check the layout. I'm planning on using my wide nickel strip this time instead of the skinny layered strip that I used for it last time. I'm anticipating that the build of this pack will be very similar to the one that I did in the last Hummy build that I did, so the Black Mamba build. Check out the video up in the iCard. That battery had braid and what do you call it? It had braid going across, and then it had cables going along the sides. So we'll see what we're going to do for the layout, but hopefully it'll be a little bit cleaner than what I did 4 years ago with my first battery. So let's go ahead, open it up, and start on the battery building process. Alright, so our first step is going to be to take off the enclosure here. So got 10 screws to get out, and then we'll be inside. As you can tell, this thing is quite well loved. The motors are worn, the mounts are worn. This is actually the second set of motor mounts. The enclosure is scuffed up, there's scrapes on it, but man, this thing is a lot of fun, and it has over 1,600 miles on it, so I'd like to keep that going with the new battery. So let's get off this enclosure. Oh boy, look at all those rocks. I had to grab the vacuum real quick. Alright, you guys may be wondering why there are so many rocks in here, and that's because the rear end of this enclosure is technically open, so rocks can get in a little bit through where the phase wires are, which is annoying. So that's why I did 2 more screws on my new Hummy build, but it didn't seem to break anything, so that's good. But we've got a lot of electronics going on here. I've got a buck converter for lights, I've got a Maytech receiver, the DB6, and then the BMS is underneath. So I think I'm going to swap the BMS out for a small one in this build, so I have a little bit more room. So we're going to be taking the BMS and battery out of this board completely, and they will get completely replaced. So I think what I'm going to do is start unplugging stuff and see where I run into hiccups. I know I did permanently attach this charge port to the enclosure. Again, this is my first like higher end DIY build, so I didn't know as much what I was doing then, so that will not be happening again. But I will probably have to cut that off, unfortunately, and replace that with one that's attached via XT30 rather than permanently soldered. So let's go ahead and start unplugging stuff. Oh boy, look at all that. It's actually crazy that this much stuff got inside. All kinds of road stuff. Man. Just replace this foam because it's super old. Good old reliable DV6. So something like I want to disconnect the bucking battery, so it looks like I currently started that one as well. I have a new probe here, just unplug that. So it's like now. Trying to see if I pull the battery out easier. Really need to. This discharge is technically it's not BMS bypass. It's a long time ago, so I remember when I did. Look at this a little closer. Alright, so I've decided to snip the negative cable here. Now the pack negative is completely disconnected, and I can feed this out, and I'll use this on the new BMS, attach this to the same spot as the battery negative. So that disconnects that part. Then we're going to clip through this big chunk of cable here to disconnect both the charge port and the battery positive at once. So hopefully I can snip through this. There we go. Part of a loop key wiring harness here. Now we have a battery that is almost free. We just need to chop the charge port off. I really would rather desolder this. Should be pretty quick actually. Alright, the battery is now free. Let me just make sure that I don't short it out. We have two leads here that are a direct short on the battery, so I'm going to put some tape over that. I guess I don't know exactly what I'm doing with this battery yet, but now we should be able to take it out. So I have like a big piece of wood that I have a 14S8P battery sitting on right now that I haven't been using for a while. So I'm just going to slide this out and probably put it on there. If I make a video about this pack again, I'll probably show you guys how I disassemble it and turn it into something else. Right now, I don't really feel like unwrapping everything, but basically how this worked is all of the series connections are on the outside, going pack to pack to pack to pack. There's insulation between the two in the middle, so it goes down and back. And there's also series connections in the middle. It makes it take a really long time, so I'm thinking I'm going to do braid across the middle groups, just like I did on the last battery I built, like I mentioned at the beginning. So let's go ahead and take this out. There we go. Now we have a blank canvas that is filled with rocks that I got in my enclosure. I clean those out and then we can start laying out the new pack in here. And like I said, I think what I'm going to do is copy what I did in the last pack, which is you run these cells back to back. In the center, you have them attached with braid, and then along the outside, you only have to do, for this pack, it'll be 6 connections, I believe, and then your 6 to 7 connection is taken care of by the braid. You don't have to have any weird thing hanging off the end, and it just makes it a lot easier overall. So I'm going to pull out the, actually I'm going to put this away, and we'll start prepping all the cells. I have to take all this stuff off. I'm not going to record it because it's not very interesting. But we'll take all this stuff off, and then we'll re-glue them together in the right shape and put fish paper rings on them, and then we can start welding. Alrighty, so we've got all of our cells glued together, wrapped in fish paper. I don't actually have enough fiber tape. You can see it up there. That's all I've got left. So I can't really wrap these in tape yet. So I think I'm gonna order some tape so I can make sure they're all tight, but it's time to start cutting up the nickel. And I happen to have like this random roll of 0.2 by 25 millimeter nickel. And I say random because pretty much all I use nowadays is either pre-cut or stuff that I bought in a big batch, which was 30 millimeters by 0.15. The 25 millimeters is actually the perfect size for 18650 cells, which I like never use. So pretty convenient that I have this because it's the perfect width for these. So basically my idea is that I'm going to cut these a little bit long, and then I'm going to split the end of the nickel and then fold over a flap for the top and fold over a flap for the bottom. And then I will solder a 12 gauge cable from the top one and a 12 gauge cable from the bottom one. So that way we kind of have the current split up a little bit more evenly, and I can carry those over the P groups or the S groups, because they'll be sitting next to each other in the board, sort of like that, and they'll carry the current across like that. For the cross groups like these, haven't fully figured out what I'm going to do yet, because when I was doing the other Hummy pack, I had pre-cut nickel strips with like the tabs that stick over the top. So if I choose to do it like that, I'm going to need to solder, or I'm going to need to weld on an additional piece across, like from the bottom, from the bottom sticking up, which is possible, and then I could solder the braid across, but that does mean I have to double stack, and that gets kind of annoying. So I'm going to think about what I want to do there, but I'll probably end up soldering it on top and then doing the braid, because honestly it just works out well that way. So we'll see. Let's cut some nickel. Alright, so you can sort of see here the idea that I've got. So we got to cover all 7 cells. Ideally we want 2 12 gauge connections between each of the series groups. So we got 2 strips so as to not hang over too much. Although I suppose I could hang over. Maybe it's not that big a deal. But this isn't too hard to do, and it should work out well. So we'll have one going from here to there, and the other going from there to about there. And I think that'll spread the load out well enough. It does mean that the current is kind of split across this width and this width, but if you divide 25 by 2, you get 12.5, so that's 12.5 millimeters by 0.2. That can take quite a bit of current, and if it's divided by 2, that's even better. And honestly, we're only looking at about 100 amps out of this pack, so this should be more than sufficient, even with it being sort of bottlenecked through those bends of nickel. And the plan is kind of to press it down against it and tape it tightly against the other cells. So it's probably even less of a problem, but kind of just going through the thinking with y'all there. So I'm gonna make a whole bunch more of these, which is somewhat annoying, but it'll be easier for the cross pack ones, because the cross pack ones can just be straight, and then I'll make another piece that goes up and will attach across. So really, think about, need 6 on each side, right? 1, 2, 3, 4, 5, 6. We need 1, 2. Well, this one will be, say this is pack main negative, so that'll be our discharge. It's going to go across, so we need 1, 2 there, 1, 2 here, 1, 2 there. So that's 6, 7, 8, 9, 10. And then our pack positive will be here. And we'll have to run the positive cable down the whole length of the pack. Done this a couple times, really makes no difference at the end of the day. And it makes the cabling and the soldering and nickel so much easier. So that's my plan. I've been talking about this a lot, but these battery videos are always supposed to be super informative, and I want to explain what I'm doing. So that's what we're doing. So it's time to make, 11 more of these? Shouldn't be too bad. And that was the final snip of the nickel cutting. We've got 12 bits to go from here to there, there, there. And we've got 12 bits for the centers. We do need the positive and negative, but those are going to be a little bit different length since I want to solder in the center for a single 10 gauge wire on each. So I guess I have 2 more cuts to make, but they're a different length than the other ones. So let's get on it. That was the final cut. You might wonder why I'm bothering to cut these all long, make these intricate like finger things on the ends. Well, the main reason is because we always want to keep heat out of our cells, and by doing this it allows me to solder to this little tab out here instead of soldering directly on the face of the cell, and that keeps a lot of the heat out of the cells. So not only is it safer, but it's a little bit easier to orient the pack afterwards, and just works out well. Done it once already, and we'll do it again. So there we go. We got the positive and negative here, positive, negative, and now we got to do all the cutting for the little bits on the ends, and some rounding, and then we can move on to spot welding them on. Alrighty guys, so I've been working on the nickel for a while now. I got all the nickel strip cut, and now I'm figuring out how I want to do the pack layout. Well, I already know, but figuring out how I want to cut the nickel and weld it on and whatnot. So I started bending some of these. I got one bent here. Basically, I'm going to use these 2 fingers to go path group to group so that I can use cables, since I don't have any pre-cut nickel strip of this size. I'm using what I have, and it seems like it's actually going to be easiest to just go ahead and weld these straight on and then do the cut and bend, or I don't even necessarily need to do the cut, to be honest. I can just fold it over, but I thought I would do the cut so that it wouldn't overlap on the sort of slanted parts. But looking at it again on here, even if I just fold it over, honestly it'll be fine because I don't think they're going to touch anyway. So I'm probably not even going to bother cutting any more than just, you know, another one to match up with that one, but we'll see. In any case, I'm going to go ahead and weld the entire pack now. So we're going to weld on the inside or the outside pieces, and then all of the cut inside pieces. So that'll be on all the internal parts, and then these will need a second piece welded on to do the series connections across the top of the pack, like in the Black Mama video. I'm really not going to show too much of this welding process because I've shown it a bunch of times. It's just super repetitive. Take the welding probes, set the value, tap them on there a bunch of times, and continue. So I'll link another video up in the iCard up here, and you can check out some more of the welding process there. But we're just going to kind of speed through this, and then I'll catch up with you guys when we have got all the packs welded. Alright, so I just went ahead and cut my other series pieces of nickel, and I welded one up just for testing. So what we're doing here for the series across the pack in this direction is double stack nickel. And normally nowadays we don't really like to do double stack nickel, but I have tons of space on here to get a bunch of good welds, and I don't have any pre-cuts, so this is the best alternative for me. So it'll be the same thing on the positive side, which makes it a little bit harder to hit this point, but I've been welding for so long that it's pretty easy at this point. So I cut all those, got those right here, all 12 of them, and that'll be for all of the connections across the center of the pack. For weld settings, I'm welding with 37.5 joules on each of the ends, and then for these, where it's double stacked, I'm doing 45, sorry, and that seems to stick pretty well. So we're doing pretty good right now. I'm going to finish welding all of the regular pieces, and then we'll do all of the series ones. Alrighty, we went ahead and got all of the nickel welded onto the pack. We got all the secondary bits welded on and all of the end bits. They look kind of funny right now with the folds. It'll make more sense once they have the series connections across them, but it's really just to isolate the soldering surface from the cells, and then once I've got the cables on there, I can put a nice piece of tape around the end to hold it in place so it doesn't vibrate all over. And then each end piece will probably get a piece of fish paper on it, since the Hummy deck does have a carbon layer in it. Just sort of good insurance on the outside to make sure it doesn't short. Now we have two left. The negative down at that end and the positive at this end. Both of those still need to get welded, but my plan is to solder on the positive and negatives to the actual nickel first, and then we'll go ahead and weld them on after they're soldered. It just kind of, again, keeps the heat isolated off the cells, and it's actually easier to solder onto a separate piece of nickel than it is to do it on here. So we're going to do that next, and then I'll take some video of that, and then we will start doing all the series connections. If you're wondering what this liquid or whatever that is, I'm not 100% sure, but it's not from the cells. It was either the adhesive from the fish paper breaking down, or the silicone on the cells before that soaked into the paper, but it's not from the cells. Alright, so I finished soldering and welding both the positive and negative. Got them set up here just to see how it looks. Everything looks about right. So now we need to do all the series connections. So we're going to be doing the tabs across each other. Tabs across, tabs across, tabs across, tabs across. So there's 1, 2, 3, 4, 5 spots to do joints on. So I'm going to go ahead and cut a bunch of 12 gauge wire. I want to do 2 per, just like in the 14S6P build. Check that out up in the iCard. Same exact method, and we'll get those stripped and then we'll solder all of them. All right, so I've got one pair here ready to solder. I'm only going to show you guys how I did one, and then I'll just time lapse the rest. But for this first pair, I got them lined up and ready to solder. I've got some FR4 here, which is just fiberglass stuff basically, to help support it while I'm soldering. And I've got my wires cut So I've got my two 12-gauge cables. Solder one on the top and then one slightly below it. Just like that. And then we're going to repeat that 4 more times. Should be fairly straightforward. And there you go, there is the first joint. 4 more to go. That was pretty smooth. And that should hold up perfectly fine to the vibrations that will happen in this deck. You can see that it clears the deck cutout as well, which is exactly what I wanted. So as with all my other packs, I will check on this after 100 miles or so and make sure everything looks good, but I think this will be just fine. My other pack that I started in a similar fashion, albeit with the pre-cut strips, has held up fine, and it's at about 270 miles now. So I think this one will be perfect. All right, so I went ahead and did a little bit off camera. I showed before these tiny strips that I put under the positive terminal. These are just kind of extra insurance against abrasion between the folded over nickel and the shoulder of the positive side of the cells. I also went ahead and put a piece of fish paper between each of the positive sides, just for extra measure. Technically, this is the same terminal across here, but theoretically, there is a chance that you could abrade through the fish paper ring and then hit the shoulder. So I just added an extra layer just because I can. So now we have all of our pieces of copper braid. And if you haven't seen copper braid soldering, go ahead and check out the Inazuma race board video or the Hummy video. I'll link one of those up in the iCard, and you can see how I soldered it there. I'm just gonna do really quick couple cuts of it here, and then that will be all of our series connections from negative all the way to positive. And then after that, it'll be time to do all the balance wires. Somewhere in there, I'm going to end up taping these together to keep them in little bricks. And then on the bottom side, I'm going to put a piece of tape along the back so it could like fold down that way and also fold up this way. But I don't have the tape right now, it's on its way. So I'm going to solder these first and then we'll tape them afterwards. All right, so right now I'm doing one of those boring things, which is just taping the packs together. I did tape these with Captain tape because I didn't have my new shipment of fiber tape yet, just for soldering. But now I'm going to go through and put a piece of fiber tape on each of these, and then I will do the underside, which is going to be a little bit annoying, so I'm going to have to flip the pack over to tape each of these to each other so they're kind of in line and I can pick it up in one piece. And then after that, we will go ahead and do the balance wires because we need to solder to each of these outside terminals. Well, here and there and there. We'll need to add an additional discharge lead for the light buck converter and for the battery plus on the BMS. So we are going to, I think, use the 14S multi-voltage BMS from JBD or LLT because it's super small. So I'm gonna go grab one of those out of my stock, and then we'll get going. All right, so I taped up the bottom here, and you can kind of see I have it split into 3 segments. I don't necessarily need to split it into segments like this, but in my mind, it just makes more sense to leave a little bit of extra flex in here since the deck flexes the most in the middle. But in any case, these will be able to flex like that since I'm not going to put the tape tight on the other side. But what this allows me to do is to kind of keep the pack more together. So if I want to pick it up, I can pick it up from the underside and not have to worry about the packs like falling apart since they're all attached solidly together now. And that is super important when it comes to handling the pack. It makes it much, much easier. So on the top side, basically what I'm going to do is I'm going to run tape loosely through each of the crevices to sort of just have like a guide, and that'll keep the pack together even better. All right, so I've gone ahead and pulled out my BMS, and I'm sort of laying out the wiring template here. I like to do this before I solder any of the wires because it helps me make sure that I get them right the first time. So we've got BC0 is the black one on this side, and then we're going up that way. And this is actually a 10 to 17S BMS. So on this 12S battery, we're going to end up connecting, I believe, 4 of these wires together, 4 or 5 of them together on one of these terminals, and I'll put the diagram from the BMS on the screen at some point. But it's not too difficult, just takes a little bit extra work, and it makes it much easier for me when I'm building like other people's random size batteries to have the variable ones that have the multiple connectors. So you can see here I've started to route it, and I'm just going to go through and peel off each of the different connections along the way, sort of lay them out, and then we'll cut them all and solder them on. And on the ends here, we'll be soldering a cable, and then we'll tape it over and make sure it's all fastened tightly down. Alright, so I just went ahead and checked the wiring diagram, and most of these ones on this second connector are going to be going to this terminal. So the first plug goes 1 through 10 and finishes perfectly right there. Real nice layout going down here. 11 here is going to be the balance leads from 11 through 16 on this BMS. So these 6, these will all get attached to this terminal right here. And then this last red wire is going to come around and go to the positive on the battery. So I'll probably route that underneath kind of alongside and tape it down real good. Or I could route it over top, but I think that looks worse. So I'll probably route it underneath. But yeah, not too bad. I'll put the diagram on screen now, right there for you to check out. I'm gonna go ahead and probably cut these all to length, or I'll double check the wiring first, and then I'll cut them all to length, and then we can start soldering them up. And that's a big step because BMS wiring is always one of those little tedious things that You just got to get done. Now that we've got all of our wires cut, here's how it goes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That makes 13 balance wires, of course, but that's because we're starting on negative and ending on positive, and then we hit every single connection between them. So now we're just going to go along and put a little touch of flux on each of the corners where I'm going to be soldering a balance wire. Make a tiny solder pool, put some flux on the piece of wire, and then all we have to do is melt them together. And it should be pretty easy. On the negative end up here, we have to solder an additional wire for B-. So we have our discharge cable, which is this 10 gauge one, and then we have the B- cable for charging, which will be 16 gauge. And then in addition to that, on the positive, we're going to need to do a cable to charge plus, and then we're going to need to do a positive cable to our buck converter. Well, I'm not going to use the buck converter anymore, but for our lights, we'll need a positive to come off of the positive as well. And we'll send that all the way back up to the front where I'll power my lights, and that'll be switched by the remote. So good stuff. I'm gonna go ahead and solder all this. All right, before I put glue down on all of these solder joints, it's always good to go ahead and check the voltages at the BMS and make sure that your wire order is correct, because if it's not, then it's really a real shame. Now we're going to be measuring everything from the negative terminal, so I'm just going to go ahead and stick this over here. Should be fine. And we're going to measure each pin, and they should go up by well, whatever these batteries are at, 3.5. We'll see in a second. They're at 3.5 volts, yeah, so 3.5 volts per increment. So 3.5, 7, 10.5, 14, 17.5, 21, 24.5, 28, 31.5, 35.0, and then most of these are going to be the same because they're all in the same terminal. 38.5, 38.5, 38.5, 38.5, 38.5, 38.5, and finally 41.9. So we have just confirmed that our BMS is wired correctly. We can now go ahead and solder up the B- to the blue cable here. I'm just gonna bring this around and we'll join the two cables underneath or somewhere over here. And then we can plug our balance connectors in. Then we gotta wire the charge port, so I got a couple more wires to solder up for that. And then we have to wire the loop key again, because this ESC in here is still one that uses a loop key. So got a little bit more work to do. I'm not sure how much of it I'm going to show on camera, but I'll at least summarize it after I finish all the little wiring bits. All right, I haven't 100% finished yet, but I've tidied up a lot of stuff. Ended up going ahead and soldering the B- onto the BMS here, plugged it in, and I'm going to go ahead and open the app for the first time and double check that it sensed properly, which it should have because I used the diagram, but you know, sometimes you can mess up. So I should see it here coming up in just a second. Let's see if I can show you guys here. Also, the default password for these is usually 1, 2, 3, 4, 5, 6. We're going to set our capacity, which is going to be our amp hours of each cell times the P groups. So that's going to be 2.8 times 7, which is about 19.6. So we're going to put 19.6. Oh, it doesn't, I forgot it doesn't do decimal points. We'll do 19 there. And then cycle capacity is 80% of that. So times 0.8 is about 16. So we'll do 16 amp hours there. Hit confirm. And there you go. 1 through 12. You can see it's all pretty well balanced. Just take a second to adjust there. We got a couple groups that are barely low, but it's still well within the 0.03 voltage difference that I usually set as the standard. So we got to go through here and set a couple of these settings, make sure that the balancing is turning on at the right voltage. It did auto detect 12S properly, so that's great. And then we need to go through and set the percentage properly so it'll show up in the app correctly. So we're all good there. Next up, we got to connect the positive, the charge port, and then I think what I'm going to do is I'm going to use this switch on the BMS to turn my lights on and off, because I don't really want to use the same remote that I have in here. So I'm going to connect this switch up to a push or a latching push button, and hopefully that'll be able to turn on and off the discharge port, which is C-. C- is going to be the negative of the port for the lights. So let's get that going. Perfect. That's lead-free solder too. Look at that. Beautiful. Don't ever forget to put these things on, because if you forget, it's really annoying. Alrighty, so I'm going to try to explain what's going on here, because there's a lot of cables and it's probably super confusing. So on this side of the BMS, we have a blue wire, which is B-. B- typically goes to your battery negative, which is what we're doing with this small cable here, which is soldered straight to the B-. And then the other side is C-, and C- typically goes to your load negative and your charge negative. So we have our charge negative here, which is also got one of the thermistors from the BMS hot glued in there. We have the other thermistor from the BMS hot glued onto the positive here. These are just like fun, useful heat points to sort of keep track of. So that's why I put them there. And then we split this C- off to 2 spots, and one of those goes to our buck converter here, which is what I used to run my lights before. I was going to redo all the wiring, but it turns out that this cable that I had running to the front happens to be long enough still. Not really a surprise, but I just decided to reuse the stuff that I already had in here, and then once we get a new Z mode or whatever, we'll replace this Maytech one. So anyway, that's that. So I think that's pretty much the whole BMS setup, and then of course we have our balance wires that are all going out to the pack. So the pack is ready to get wrapped up. Everything is all glued off, and I'm just going to put Kapton tape over the tops here, and then fish paper, I think, on each of the end pieces. I haven't 100% decided what I want to do with that. I don't think Kapton is good enough personally, so I think I'm going to go fish paper, but it's going to look a little weird. So we'll do that, and then in the back here we have a loop key harness, and this looks super weird because I reused wiring, but we have the loop key mount is in the back of the board. So you have your 2 wires that have to split the positive, right? This is the discharge port, essentially. The negative side comes off and goes into the loop key and then comes back out to the positive. It looks weird, but it's correct, trust me. And then you plug this into the port here, goes to negative and positive, and then you plug it into your ESC and you have power, but only when the loop key is plugged in. So that should all work out. Pretty much ready to button this all up, so I'm just going to do like a time lapse of whatever I end up doing with covering the sides here, and then we'll close it up and give it its first charge. already the battery is done, and I have to say I'm not the biggest fan of how this fish paper on the outside came together. I really like how the Hummy one came together a bit better, but with this particular 7P layout, it's a little bit of a weird shape. Also, you'll have to excuse my crazy hair. I did the Defiant board range test today, and my hair is very long right now. But anyway, the battery came together well, and I'm excited to finally have an upgrade for this because I've been kicking along this super old 30Q battery for so long now that one of the P groups, or one of the S groups, was 0.3 volts off from the other ones, which is pretty bad. So I'm really happy to have this now. I have to do some organization back here to make sure everything will fit properly. I got to run the light cables up to the front, tape them down, but other than that, pretty much done, and wasn't too hard. I did have to do some extra steps with the welding of the extra pieces of nickel in the center, and that's where pre-cut nickel is really convenient, and that sped up the Black Mamba build a lot because I didn't have to cut the extra nickel, I didn't have to do the extra welding, and it also made the outside a lot easier too. However, this is a big upgrade over the previous pack that was in here in terms of build quality. The one that was in here before was my very first pack ever, which, great that it's still running 5 years later, but I'm happy to have something that is more up to my standards nowadays with nicely organized wires, properly soldered everything, and hopefully this will last a lot longer and stay in balance, and hopefully get me a lot more range than I was getting with that unbalanced pack. So I'm really hoping to get, optimistically, I'm hoping to get 20 miles on here. We'll see what it can do. It is only 18650 cells, and those are pretty ancient for most boards nowadays. So anyway, hopefully you found this video entertaining and interesting, and thank you for watching. I will probably do another video on this build, but thing really had to cut me off right while I was talking. Anyway, I was saying you'll probably see this board again for other wheel reviews, other efficiency tests, but I'm just really glad to have this thing back up and running. So thanks so much for watching again, and stay safe, keep on riding, and peace out.